Hello everybody, welcome back. In this video we're going to focus on two tricks which are really kind of handy when dealing with pandas. And they're not always necessary, but they can make your life a lot easier. So first we're going to import our modules and read in the data, and we're going to do this exactly the same pre-processing as we've done the last couple of videos. Really, the only difference is the sex column. We're going to keep the sex column as well to keep male and female penguins. Okay. So the first trick is to recode the male and the female, to recode the columns. So right now in the sex column it says male in all caps, female all caps, or not a number. And maybe we might want to instead have this just be MF and unknown. In fact, let's actually look at the set of penguin sex. And we see there's actually 4 entries. One time when the researcher was supposed to type in Nan, they just put a dot there for some reason. Why? Who knows? We're working with real data. Real data is a mess. So we're going to clean it up, and we're going to clean it up with the recode. So the key to the recode is you create a dictionary, and you name it recode. And then the keys are going to be the original data codes. So those are going to be male. And the values are going to be the new data codes, which we could do with just the letter M, make it a little cleaner. Female, F. Now for Nan, we have to type in np.nan because it's not the word Nan, it's actually the NumPy value Nan. And we're going to send that to unknown. And we're also going to send that dot to unknown because whoever typed that was probably having a little bit of a long day. And they just typed in a dot when they shouldn't have. And now given this, we can go ahead and recode. So we can say penguins sex is equal to penguins sex dot map. Map is the method we are using, and we need to say what we're going to use when we use our map. We're going to use the dictionary named recode. So now let's look at our new penguins. And we can see that the sex column has now been all cleaned up. It's just got M's, F's, and unknowns. No more dots, no more NANs, no more all caps. We've got complete control of what our column looks like. And in general, this is really a useful pre-processing data to format it the way that you want. So our next example is going to focus on the apply method. And the apply method is motivated by the following example. Suppose we want to make a histogram of Kalman lengths for each species. So there's 3 species of penguins, so we're going to put 3 histograms on one plot. So first we're going to make a plot, plt.subplots 1. Like I said, 3 histograms, 1 plot, only 1 subplot is going to have 3 histograms appear on it. So in order to do this, we're going to write one function and apply it to the 3 subpopulations. This is what's called the apply method. So first we're going to make our function. This is a function that makes a histogram, def plot hist. It's going to input a data frame, a column name, and let's just say it inputs the transparency as well. And this is going to be a nice quick little one-liner, ax.hist df call name, alpha equal to alpha. And now with this, we can go ahead and make our histogram. So we say penguins.group by species. So penguins.group by species just gives us our grouping of the penguins by species. And now we do apply. We apply our function plot hist. And now we need to specify the parameters of the function. So we don't need to specify df because the df is already out here. It's kind of acting implicitly. but we do need to specify the other parameter, so we'll go with length. And then we'll say alpha equal to 0.5. And now we got nice little pretty partially overlapping histograms for each species and giving and plotting out the length of the columns. Now we might want to give the user a little bit more control and also let the user specify more input. So they could also specify the number of bins. And let me just double check to make sure I don't screw this up. So yeah, so we're going to say number of bins, and then we're going to say bins is equal to bins. And now they can call this with the bins being equal to 40. Let's go ahead and specify that alpha is equal to 0.5 and bins is equal to 40. And now we see we got the same thing as before, but with a little bit more bins. All right, and really you don't know in advance what arguments you're going to want to use. So probably the best thing to do would be to use quarks. So to motivate the use of quarks, let's look at what happens if we, at ax.hist, how that works. Remember, this is how we check the documentation. You do question mark for ax.hist. And we see there's just an absolute, just tons and tons of potential things you could specify. And we want to make a flexible function which is going to work for all of them. So to do that, we type in basically the same stuff as before. But now we just type in quarks instead of the last things. Recall, quarks is for keyword entries, so we still need df and call name to be the same, but these are the keyword entries, so we just type in ** quarks. And then similarly down here, our keyword names are also just going to be ** quarks. And now it works the same way. But if we only wanted to specify alpha, it would still work. Or if we only wanted to specify bins, it would still work. Let's make 37 bins, why not? Alrighty. And there it defaulted to alpha equal to, whatever it defaults to, maybe 1. Not very pretty. I don't recommend not using any transparency at all, but this does illustrate the concept. Let's go back and make a more nice, better value of alpha. Oh, I forgot the comma, sorry. And yeah, this looks a lot nicer. And we're not completely done. Really, we should add legends and stuff like that. But that's may be a lesson for another day. We are going to stop here. The main point is that apply can be really useful when combined with group by to make the same visualization for every subset of your data. And if you use quarks, you can get really powerful plots that give you very flexible functions. So this is where I'm going to stop. I will see you again next time.